Hello everyone, I am your host Professor Rage Uday Kiran. Welcome to my channel on data analytics. In this video, we are going to learn the key reason behind the popularity of Java, which is platform independence. Before starting this course on Java, I would like to educate my viewers with the following information. Object oriented programming concepts or OOPS concepts existed long before Java. However, Java only made the concepts popular. Keep in mind that OOPS did not make Java popular. Instead, it was vice versa. The main ingredient that made Java popular was the platform independence nature. It means you write Java code on any machine running any operating system. You are guaranteed that it can run on any machine having any operating system. So please remember this proverb. World adopts only those technologies that have real value. For instance, in the database field, oops does not had significant value. So this topic was stopped from learning in the field of database systems. Now coming back to this lecture, the outline is as follows. First, we talk about the heterogeneity that exists in the computation environment. Next, we talk about the portability issues. Third, we talk about the idea and the motivation behind the concept of virtual machines. Finally, we briefly touch on Java. In the later videos, we will cover Java in depth. Coming to the first topic on heterogeneity, we are going to cover the following three parts. The first one is what are the main parts of a computing device. Next, we are going to talk about how the communication happens in a computing device. Finally, we look at the complexity of a computing device. When we talk about computing device, please keep in mind a computer is a computing device. Okay, phone is also a computing device. A calculator is also a computing device. So on and so forth. Now, if you look at any computing device as such, it will have three main components. The first one is motherboard. Why this is the first component? Because peripherals are connected to the motherboard. That is why it is the first main component in a computing device. The second main component in a computing device is obviously the CPU, which we call the brain of the computer. Before talking about the third important part of a computer device, please pause this video and think what will be the third important component for a computer device. Please pause and think of an answer. Once you have thought of an answer, continue this video. to know about the third part, let us ask this question. Okay, do CPU directly communicates with a motherboard? Can a CPU communicate directly with a motherboard? Think whether it is true or false. The answer is false because a CPU cannot directly communicate with a motherboard. Although CPU sits on the motherboard, it cannot directly communicate with the motherboard. Between the CPU and the motherboard, there is a third main component that is called operating system. Operating system has several components, but the most one is kernel, with which most of the communication happens between the CPU, motherboard, and the peripherals. So, operating system is the third main part of a computing device. So, overall, the three main components of a computing device are motherboard, CPU, and the operating system. Now, why do we need to know these three parts? Because when we are talking about the communication that happens, like users are opening the applications and they are communicating with the operating system, then these three parts have to be kept in mind. So in this figure, I am showing the concept on the left hand side, and for that concept, I am providing the examples on the right side. So for the operating system, I am taking Linux as the operating system, and for the application, I am using the terminal. If instead of terminal, you can think of programming language also. For example, C++, C, Java, whatever it is. You can put it's just an application. Now, the fundamental question that comes in mind is how do applications interact with OS kernel? Please pause this video and think how the applications interact with the operating system kernel. If you found the answer, and if the answer is system calls, it is correct. Otherwise, please remember that any application can communicate with the operating system only through system calls. So let us see an example of how the system calls exist. So to explain the system calls, I am providing the sample code here. C program. You can find more information about how the system calls work at the link provided below. For illustration, let us look at the printf statement. Okay. Many of us use printf statement in C quite often. Now the question is, does the operating system understands the printf function? Yes or no? Make an answer. The answer is no. Operating system do not understand the printf function because operating system only understands system calls, and printf is not a system call. So what actually happens with the printf function is as follows. First, the printf function will go to stdio.ih file, and this file will call the libc header. if your operating system is Linux. This libc file will convert your text into a character string and then uses the system call write, okay, to send the message on to the terminal. This is the process of communication that happens. So although you write printf, for the operating system, especially the Linux operating system, to print it on the terminal, it converts into a system call of write. Okay, so this is how the system call works. Now let us understand the complexity. In the real world, we have several operating systems. For example, Linux and Windows. Now the question is, do the system calls remain same across the operating system? For example, you can assume that the motherboard and the CPU are the same. Okay, you are using same Intel CPU and the motherboard also the same. You are only changing the operating system. Okay, the computing device is the same. You are only changing the operating system. In that case, do you think Windows and Linux have same system calls? Yes or no? Please choose a side. If your answer is no, then it is correct. Although your hardware remains the same, the operating systems may use different system calls. For example, Linux uses a monolithic kernel. So all the system calls exist in one single file. In contrast, in Windows, the system calls are connected using a microkernel that has multiple dynamic link libraries. Okay, so the way these calls can be called are completely different. So let us see how it happens. Previously, we have looked at how a program gets converted into a system call for Linux. Now, if we change Linux to any operating system, say Windows, now what happens is printf will write to a write file output stream. This output stream in turn is taken by NT write system call and then outputs it to conhost.exe executable. This executable will take the text and then prints it on the terminal. So this is how the things happen. So the system call for Linux is write and std out and the file number, that is generally 4. For Windows, it's a completely different. So although your program looks similar, the way the code gets converted into the machine language will be different depending upon the operating system. So this heterogeneity in calling the system calls will raise portability issues, and we will now talk about it. Okay. Coming to the issues, since system calls are different for every operating system, we have different compilers for each operating system. So these compilers have different APIs or libraries. Because of this reason, okay, when you write code for one compiler and bring it to another compiler, bugs can arise. So let us see with an example. If you are writing your C program in Windows, we can use void main. If I take the void main function and try to execute in the Linux, it will create an error because for Linux, the return type has to be an int, not a void. Similarly, if you take a Linux program which has int as the return type for the main and try to run it on the Windows machine, it will be creating compilation error because the Windows C compiler wants main to be void type, not an integer type. So such kind of bugs can arise. Similarly, the libraries can vary for Windows as well as Linux. Okay. So this is the problem with the heterogeneity. So how do we solve the heterogeneity? We solve it using the ideas of virtual machines. Before we go into the idea of virtual machines, we should understand what is the reasons for portability issue. Means if I write program for one operating system or one compiler, why can't I execute the same program using other compilers? To understand the reason, we have to think about the conceptual thinking behind the programming language. For programming languages such as C, Fortran, and all, when these languages are being introduced, at that time the researchers or the programmers thought that the computing environment and the execution environment are one and the same. Means developers will code and execute in the same environment. For example, the coders will create the file, will compile the file in the same machine and execute it in the same or similar machines. If you change, it will not work. That was the assumption. So, this reason, this tight coupling of computing environment and the execution environment was the reason for portability issue. So, the solution to resolve the portability issue was with two concepts. One is the abstraction and the divide and conquer. Means what people have done is computing environment was split into two environments. One environment for the developers to write their code. Another environment for executing the code. So the thinking is as follows. Assume there is one theoretically one machine is there in which all developers will be writing code for it. And the beauty of this theoretical machine is it magically converts any code that is written by the developers into operating systems machine language. That was how it was thought of. And that theoretical machine is called virtual machine. So let us see how it exists. So there is a virtual machine first. Okay, so we are talking about the developer environment. So, so assume that there is a one virtual machine where developers will write their code. This virtual machine can be on any actual machine. Okay, machines are on any real world machines running Windows, Linux, Mac OS, whatever the operating system is. We do not care. Okay, the coders don't care. The coders only care about the virtual machine on which they are writing the code. Once they write the code, they will give their code to some magic. What that magic? We will look at it further. But the duty of this magic is depending upon the execution environment, the code has to be executed. How the magic is going to execute, the developers don't have to know. It is not at all concerned for the developers. It is only concerned for the magic to ensure that the code can be executed on any machine running any operating system. So that is the duty of the magic. This magic is implemented in several ways. For now, we look at the Java. How Java does it. Java does the magic using virtual machines. Okay, so you write code in one virtual machine and then give it to the virtual machine in the execution environment, and that will compile it to the native code. This is the duty of virtual machine. So this is the basic architecture. First, users will write the code which they compile it using Java compiler. They will create an intermediate code called bytecode. This entire thing happens in one virtual machine, developer's virtual machine. This class file, when given to another virtual machine, okay, this is on the execution side. The virtual machine will perform these three steps: class loader, bytecode verifier, and JIT compiler, and then create the native code. These three steps are the magic that the JVM will perform. Okay, here we are saying it as native code, but in reality, the JVM communicates using the system calls of the operating system. So this is how it happens. So this is the basic architecture. Please keep in mind that JVM does like this. Python will not perform like this. Okay, Python performs slightly different, because in Python you don't need to write the entire code and you don't need to compile the entire source code, which is the requirement. In Java, you have to compile the entire source code and you have to execute the entire source code. That is the requirement of Java, which is its weakness. Okay, in Python we try to overcome this weakness by executing line by line. So overall, this how the concept of Java and Python looks like, but slightly different in Python. Okay. Now some fundamental questions. Let us look. Okay, everyone, please pause this video and look at the figure and try to answer this question. On the developer side, okay, we are provided with Java development kit for the coders. Okay. Now, if the developers are working in Windows, Linux, or Mac OS or any operating system, will the JDK remains same or different? Okay, assume there is a user there is a Java coder who is working on Windows environment, and there is another Java coder working on Linux environment. Do you guys think that JDK will be same for both the coders or different? Please pause this video. Look at the figure and choose yes or no. The answer is no. JDK does not differ with respect to operating system. Since we are thinking that the coders will dial up code on a virtual machine, imaginary virtual machine, JDK will remain the same whether you are writing the Java code in Windows or in Linux or Mac OS. It the JDK will remain the same. Now let us look at the second part, that is computing side. Okay, so for computing environment, for execution environment, we have Java virtual machine, right? So is Java virtual machine different for the uh, implementers for Windows, Linux, and Mac OS? Is JVM different for the operating systems? Please pause this video and choose yes or no answer from this figure. The answer to this question is yes. JVM, okay, at the execution side is different for each operating system. Okay, so JDK is constant for all the users, but JVM, that is Java virtual machine or Java runtime environment, we actually call Java runtime environment, JRE, it is different with respect to operating system. Okay, now that is why people have started using Java, because you code on any machine, you are guaranteed that Java runtime environment will ensure that it works on any machine. So that was the main reason. After Java became popular, people have started using OOPS concepts for the coding of Java. These OOPS concepts, that is class, object, encapsulation, inheritance, polymorphism, and abstract, are widely used, and we will be talking about them in the later videos. Thank you very much. If you like our work, please press the like button and subscribe to our channel